Before starting task 5A, you'll have noticed that there's a set of 3 commonly used area formulae on page 75 of your book. It might pay at this point to pull that out and have that with you as you attempt these problems. Now in task 5A, we're looking at the areas of some regularly sized shapes. Now please notice area means the amount of material within the shape. Perimeter, remember that you're walking around the shape. You walked around the tennis court, you walked around the netball court, you walked around the circumference of the oval perhaps. In the first instance, number 1, we've got a length of 3 and a breadth of 3, or a width of 3. So length times width, 3 times 3, 9 centimetres squared, or squared centimetres. We use the square notation because you're really multiplying centimetres by centimetres. Question 3, we're looking at first instance of a triangle here. Now, you'll notice that if I multiplied 8 by 6, I'd be perhaps mapping out a rectangle, a much, much bigger shape. A triangle is defined area-wise as half by the length by the base. It pays to really write out these formulae, or base times height you guys are using. So it's a half times 8 by 6. Now if you know that 6 eighths are 48, you can do that and have 24 centimetres squared. Now if you're a little bit uncertain about how to do that pen and paper, that's why we've got a pretty good calculator for you to use in this course. So going through on the Casio, that triangle problem, that would be a half. Now a half is 1 divided by 2, a half times 8 by 6, 24. Please, you're most welcome to use a calculator as you go. If you're really worried by the fraction, you've actually got a fraction key notation you can enter. And then that times 8 by 6 and the 24 squared centimetres. Please don't forget to put the units in as you do these questions. In question 4, we're looking at the area of a circle that has a radius of 2.4 centimetres. Please remember the area is the amount of stuff within the shape. If you were to walk around the shape, you're covering the perimeter. It's the amount of stuff inside that you don't walk around the area. Now for a circle, an area is equal to pi times the radius squared. Now your calculator can do the hard work for you there. Remember that you find your pi button on many calculators as a secondary key. On the Casio I have here, it's actually above the times 10 button down the bottom. So pi, and the beauty of this is I can see the entry quite neatly, times 2.4. Now this calculator has a square button. So if I go 2.4 and press the x squared button, that squares it for me finding the answer of 18.10 centimetres squared, or squared centimetres. Similar tactic can be employed for 5, but the radius in 5 is 1.5 centimetres. In question 8, a real temptation is to try to do a question like this in one step. I really have to break it up into 2 parts. Part 1, if you like, I find the area, and then once I know the area, I know how much the square metres cost to be laid with tiles, I can work my cost. Let's do the area first. So this is, having drawn the shape of course, the amount of stuff within the shape. So 4.1 times 3.2. That gives me 13.12 square metres. Now, I know that each square metre is $70. I have 13.12 of them, so the total cost by the 70, hopefully includes the dollars as well, $918.40. Moral of the story here, do the area first, having drawn a shape, then concentrate on the second part. Now, assessment-wise, a teacher can always assess on part of this, but important to make a bit of a start.